welcome to organ analysis. So this is solution video of those questions which I am attached with my previous video, that is oxidation reaction part 4. So if you haven't checked yet of those videos, so I would suggest to go and check out those videos and download those questions from the description of oxidation reaction part 4. Okay, so go and download it now. Now let's solve these questions. There is nothing not big question. This question was quite conceptual. Okay, I am already written over here this solution of this question due to shortage of times. So let's start. Okay, so this is a question number 1. So you have given the structure like this, and you have to put you have that reagent, that is lithium and dry ether. Okay, so what happens in this type of reagent or this type of reactions? Okay, so there is a reactions of metal halogen exchange type of reaction. Okay, so what is metal halogen exchange? That is this lithium is at first exchange with one of those iodide, that is iodine. So this is happening over here, that is there is a bond of iodine, that is lithium is positive and there is a negative charge over the carbon. Now see, this is a 4-membered ring. This 4-membered ring is very much unstable, and that is very much strange ring. Okay, so it always try to fragment it, and like this way, this negative charge goes here and these bonds go here, and this iodide will leave from the system. Okay, so there is a formation of this type of compound, and two double bonds arise in those positions. Okay, so there is forward that is how the reaction proceed, and how this product how this type of product from here to here, what is the driving force of this reaction? That is the driving force of the reaction is there is a 4-membered ring which is very much strained. So the product is also very much unstable due to planar. Now see why the product is unstable. Now the product is unstable just because of due to loss of planarity. This is also a bridged type of compound, but although this is a bridged type of compound, but it can't get planarity, so it is very much difficult to attain this type of structures. Okay, so although this is very much less stable than, but this product is formed just due to this release of strain. This is 4-membered ring to release the strain. Okay, so this is the driving force of this reaction. Okay, so this is your product. This is your product. Now let's come to the question number 2. Now the question number 2 is very much important, and very much 2 or 3 type of reagents was given in this question. Now see, this is, you have given that this type of compound, there is three different type of three double bonds are present, in one here and one here and one here. Okay, now there you have given this CaCl3, that is chloroform, and TBOK, that is tertiary butoxide, as a base. Now this base, now what the reaction process and how this type of product is formed. Now see, this is your, okay, so this is your chloroform. Now you have put in the base like this, and this will abstract the proton from here and the negative charge over the carbon. Now it will form this type of negative charge, and one more Cl is removed from the system, and it forms the carbene, that is called dichlorocarbene. So this carbene is called dichlorocarbene. Okay, now this dichlorocarbene is not much more electrophilic compared to normal carbenes like this. Okay, this is also a carbene, but this carbene is not so electrophilic compared to this one. Okay, so why this is not why this is not so much electrophilic? Just because of this 2 chloride Cl atom is present over this attached with this carbon atom. Okay, so now this now there is a possibility of attach of this position also, and this position also. Now this I am already said in my previous video that if a reagent or compound is lower in reactivity, that selectivity is much more higher. That is lower reactivity, selectivity higher. that is selectivity higher. Okay, so now this double bond has a very much electrophilic compared to these two. Okay, just because of it is much more substituted, so it is very much electrophilic compared to this two double bond. Okay, so that's why this product is formed. Now how this product is formed, this is nothing but this position and this way. So now this type of bridged 3-membered ring is formed with these two chloride with these two Cl atom. Okay, now you have given this one, that is sodium in liquid ammonia. There is one kind of Barch reduction, you can say, which is one type of reduction actually. So the reduction proceeds that the reaction of the reduction after this compound is given that these two Cl bonds are cleaved, that is two hydrogen are substituted by this. We all know that how the reaction proceeds, that is sodium will give the sodium plus and there is a single electron from here, and this electron will react with react of these two Cl. We all know the reaction mechanism of Barch reduction. If you don't know the reduction of Barch, how the mechanism proceed of Barch reduction, I will make another separate video for those Barch reduction. Okay, so this is your overall product. After this, those two Cl atoms are leave from the system like this way, and there is a proton which is attached from this removal of this two Cl atom. Okay, so this is your product. Now you have given this type of compound, that is DDQ. Now what is DDQ? Now I have already given the structure. What is DDQ? Structure of DDQ. The structure of DDQ is like this. Okay, so this is your DDQ. Now what is the name of DDQ? That is 2,3 dichloro 5,6 cyano parabenzoquinone. Okay, so this is the overall name of DDQ. Now what is the role of DDQ? Dioxin is just a solvent. Now DDQ as a very much important oxidant. I am not mentioning the in my oxidation reaction videos, that is what is DDQ. Now here we are discussing that what is DDQ and how the reaction proceeds. So DDQ is just very much oxidation, very much good oxidant, and the oxidation just very much higher oxidant, which is very much higher highly reactive, just because of these two cyanide atom is present over this with this parabenzoquinone. Okay, so this is how the reaction proceeds, and this is the oxidation reaction, and it has a very much important role to form a compound, this type of compound to form a aromatic one. So this is your intermediate. The product directly forms with this ligand from here to here, that is in presence of DDQ. So it has a very much important role to aromatize a compound. Okay, so DDQ has a very much important role to aromatize a compound. Okay, so now see the aromatic of this compound, it first will oxidize these two positions, that is in this way, that is this double bond, these two double bond are formed, this two double bond, that is which I am indicating this green color, this one, and this one, and this is your overall intermediate. And now this intermediate readily forms electrocyclic ring opening, and to form this type of compound, that is called aniline system. We all know what is aniline system, that is 10 aniline. Okay, so this is a bridged positions. Now this compound forms readily, and how the electrocyclic ring opening takes place, that is this way. Okay, so this is your product from here to here. Now that's how the electrocyclic ring opening takes place. So this is a very much important concept of DDQ. Now DDQ has an important role, that is it will oxidize a compound it will oxidize a compound, as well as it will convert one compound to aromatic one, okay, which have a tendency to aromatize. Now this is your overall question number 2. I think this is all about this question. Now let's come to the question number 3. Now the question number 3 is a very much important, the first step, that is you have given the sodium, xylene and water, and this is very much important name reactions also. This is called acyl ester condensation. Okay, so this is acyl ester condensation, Now we all know what will be the product, so this will be the product. I am not going the overall mechanism. Okay, so this is your, from here to here, this will be the product. Now the important part is this reagent, that is copper sulfate in presence of pyridine. Okay, so copper sulfate in presence of pyridine has very much important role. That is, if a compound contains alpha hydroxy carbonyl compound. Now what is alpha hydroxy carbonyl compound? Now this is your carbonyl component, and this is the alpha position of this carbonyl group. Now this has a hydroxy group, and now this overall compound is called alpha hydroxy carbonyl. Okay, so this is alpha hydroxy carbonyl. Now this will oxidize, this OH will oxidize in presence of copper sulfate by accept a single electron under basic condition. Okay, by accepting a single electron, that is, it follows the single, maybe this reaction follows the ACT process, that is single electron transfer process, and this, in presence of basic condition, it will oxidize this OH group to ketone. Okay, so now this is your product after this copper sulfate and pyridine reaction. Now we have given this NH2 and HCl and NaOH. Now we all know how the hydrogen hydrogen is formed. That this is your hydrogen derivative. These two ketones are readily converted to their corresponding hydrogens. This is called hydrogen. And now this hydrogen is very much acid sensitive. Okay, so this hydrogen is formation should be carried out in optimum pH, and that is why the buffer is also used, that is NaOH in presence of acetic acid. Okay, so now this buffer is just used just because of to maintain the acidity of the overall reaction medium. Okay, so this is your hydrogen. Now the very important role comes, that is this HGO. Now what is HGO? Now we know oxygen has 2 minus, so this has to be +2 state. Now let's have a look how this product form from here to here. Okay, now let's know the mechanism. Okay, so HGO, what is the role of HGO? HGO has a role, that is, it is a good oxidant. It's an oxidizing agent. Okay, oxidizing agent. Okay, this is also an oxidizing agent, which I am not mentioning on my oxidation reaction series. Okay, this is, you can include this oxidizing agent also. Okay, now let's look how the reaction mechanism proceed. Now see, if I compound, like we have taken a compound like this is a hydrogen derivative. Sorry, this is your hydrogen derivative. Okay, now you have to put this HGO, that is Hg2 plus in medium. This nitrogen has a lone pair of electron, it will attack over this Hg2 plus. Now what will be the form? Now after that, if we put this one in, so one hydrogen, and this is Hg, this is Hg2 plus. When we attach to nitrogen, it will reduce to Hg plus 2 to Hg plus 1. Okay, now this has a lone pair of electron, it will push back over here, and this will remove from the system. Now see, from here the product which is formed, that is this, that is positive, and this is negative. Okay, so this is your overall product. Now there is a chance to leave of this hydrogen, and there is a formation of negative charge over here. That negative, that is minus of H plus. Okay, and there is a negative charge over here. Now these bonds go here and this will go here, and we all know how the nitrogen is removed from this type of compounds. That is, this one is a negative charge, and this will form this one. Now this will remove from the system, and it will form a carbene. Okay, so just why this is carbene? Just there is a negative charge, and this bond, this nitrogen will leave from the system as it contains its own bond pair electrons. It will remove from system. That is why there is a formation of carbene. So this is your overall carbene. Now if this is overall mechanism is follows over here, now here is also formation of 2 carbene. Okay, and now how the formation takes place. Now there is a formation of this one, and double bond in, there is a plus and here is a minus, and this is also over here negative, here positive. Now this will form your carbene, this one, and this will remove this carbene, neutralize by removes of hydrogen from here also and here also, and they takes up hydrogen over here, and there is a formation of one bond, and this is also go here and there is a formation of one bond. That is, one bond is already present and there is a formation of other two bonds. That is, this is called cyclooctane. Now this cyclooctane is the smallest cyclooctane. Okay, this is one of the smallest cyclooctane, and the yield of this reaction is very much poor, that is near about 8%, but this is also very much important method to formation of this cyclooctane system. Okay, so this is your question number 3 over here. Now let's come to the question number 4. Now the question number 4 is also very much important question, and now this you have given this one type of compound and you have given N-butyl MgBr, magnesium bromide. Okay, so now N-butyl magnesium bromide, what it can do as a this is just because of a soft center. This is a soft center and this will attack also the soft center over here. So this will attack on this carbon and this bond goes to the nitrogen over here. Now they have given this type of structure and N-butyl attached with this carbon. Now this nitrogen has a negative charge over the negative charge over nitrogen, and this pushed back over here, and tosyl is a very much easily leaving group, so it will leave from the system as a TS minus. Now this TS minus will abstract a proton from here, just because of it will form TSH, that is para-toluene sulfonic acid. Para-toluene sulfonic acid. Okay, so it will take as TSH, it will remove from the system as TSH, and now there is a negative charge over this nitrogen atom. Now this nitrogen atom, now here is an important concept, that is when a leaving group is present on alpha position, now there is a formation, there is a chance, so there is a formation of alkene. Okay, now what is the alpha position? This is the epoxide ring and there is alpha position, that is this one. If there is a chance of leaving group in alpha position, so there is another important chance to there is a formation of alkene. Okay, so these bonds go over here and this part will leave from the system as a nitrogen, and here is a this type of fragmentation, and there is a not a fragmentation, actually there is an important ring opening, so there is a formation of alkene. Now this alkene is formed, which is making in written over here in green color, and this ring is open up. So when the ring is open up, this will maintain its stereochemistry, that is this is epoxide is in backside, so this OH is also formed in backside. Okay, so this is how the overall reaction proceed. Now let's look question number 5, which is very much important. Okay, now see, you have given the structure like this, and you have to put the base, that is NaH, sodium hydride, and that is solvent and temperature. Now see, now there is an important chance, there is a kind of fragmentation reaction, and I am already mentioned in the question that there is I mentioned the hint, that is the question, the structure which will be formed after the reaction, that is open structure, and now you can see over here that is open structure. And another important thing is that there is a chance of fragmentation. So this fragmentation will implement over here, that is this negative charge, this hydrogen will remove from the system at first. There is a chance of negative charge. So and one more question, that if this negative charge over here negative charge is forming over here, so there is no fade and there is no another possibility of fragmentation or anything else. Okay, so this negative charge, the negative charge of oxygen over here, there is a formation. Okay, so this will of negative charge of the oxygen atom, and this negative charge goes back here, and this bonds will go here, and this TSO group leave from the system. Okay, so now there is a formation of this compound, you can easily written like that. Now you have to given this methyl lithium. Now methyl lithium has an important, this ether is just a solvent, ethyl ether, and this methyl lithium is very much hard in nature. So just because of this is attached with the lithium center, and it will attack directly over this, that is hard interaction, that is the methyl is attack over this carbonyl atom, and this bonds this go over here, and you get this product. Now why this methyl is in backside? This will go here and this is OH, so this is not important just because of this methyl is in backside. Now see, this overall OH and this methyl group, this is also in above side, so above side is totally blocked. So the methyl is one approach is easily possible, that is one more approach is possible, that is methyl is attacked from the backside. So it will attack from the backside and these bonds go over here. So this is how the product is formed. Okay, so now we have to given this tosyl chloride in presence of pyridine. Now see, this tosyl chloride is pyridine is just because of now there is a two OH is here, now here and here. Now this OH is selectively formed as OTS. Now this is just because of this is free, and this is some kind of hindered positions over here. So this is quite free from to attack attack over this by this pyridine. So this pyridine will attack obstruct from proton over here, and this is a negative charge. Negative charge over here, that this negative charge attack with the tosyl group, and this Cl will leap from the system. So OTS, that is how the OTS is formed. Now this OTS, now they have to given this sodium hydride in presence of THF. So this hydride is abstract a proton from this OH. There is only possibility and only chance there is a formation of negative charge over this oxygen atom. Now this oxygen atom has another type of fragmentation, that is this negative charge goes here, this will go here, and this will leave from the system. Now that is how this overall reaction, then this is the product, that is how, and there is a now there is a kind of ring opening. So this is also fragmentation. Now there is a two types of fragmentation is occurring on this type of reaction. So that is how this is the question is very much important. Okay, so this is kind of Groves fragmentation. Okay, this is kind of Groves fragmentation. Okay, so this is your overall product, and that is how this reaction proceed. Okay, so I think the question is very much helpful for you, and question is quite good, which I am taken for this and the solving over this over all those questions. And okay, so that's it for this video. So thank you so much for watching.